Welcome back, guys. Today we're going to talk about noble gas configuration. Okay? It's the same as electron configuration, so let me back it up a little bit from what we were doing last time. Last time we were looking at the electron configuration, right? And we were talking about just putting out the electrons in each of the shells. So the important thing is looking at where exactly every electron goes within an energy level, right? So last time I did chlorine as an example. This time, let's look at phosphorus. We're going to do P, phosphorus. Okay? We're going to look at phosphorus as our example. Phosphorus is right here on the periodic table, so I got to get to phosphorus. Okay? Remember, we work from left to right, then down. Okay? So we start off with the 1s level, right? And we go through two of them, so that's 1s2. Drop down to the next energy level. Do we see phosphorus here? Nope. So we're going to go straight through everything. Now we're at the 2s energy level, and there's two of them. We hit the 2p. We're going straight through, and there's 1, 2, 3, 4, 5, 6 of them. Okay, we drop down to the next level. Here's where we find phosphorus. So we're at the 3s, and there's two of them. And then finally, we're going to look at the 3p's. And where is phosphorus in the 3p's? 1, 2, 3. He's the third one. So this is the electron configuration from phosphorus, right? And we're looking, so we're like, okay, in the first energy level, maybe I should do this in a different color. In the first energy level, we find 2 electrons. In the second energy level, 6, 7, we have 8 electrons. In the third energy level, we have 5 electrons, so that's our electron configuration numbers with our electron configuration, okay? Now that's fine and dandy, but we got to pick out what is actually important here. What are we trying to find? What is the purpose for doing all this, right? Well, the purpose for doing all this is to look for these electrons in the highest energy level. It's the highest energy level that's important here, okay? These highest energy level electrons are responsible for bonding, okay? These are the ones that cause bonding, chemical reactions, and everything. It's these electrons, right? And the reason why these guys are responsible for chemical reactions is because how many electrons can this last energy level hold? Remember, the first energy level can hold 2, the second one can hold 8, the next one can hold 8, and the fourth level can hold 18. Well, we're here on a third level here, right? So the max he can hold is 8. Well, nature is kind of funny. Nature, to be happy, wants to have this last energy level full, or he wants it empty, right? Nature wants to have the last energy level full or empty. If it's empty, that means our last energy level would be 2 and it's full because we went through it, right? So our goal here is for bonding is to gain or lose electrons to fill up the last energy level or to empty out the last energy level, okay? Now, so that's what's important here. We're trying to find the highest level energy electrons because we need to figure out if they're going to fill up or empty out, okay? And that's how bonding happens. We'll talk about more about bonding later. But for right now, just know that the highest level energy are the ones responsible for bonding. We give a special name to this highest energy level right here, electrons. We call these guys valence electrons, VE, okay? Valence electrons. These last energy level electrons, the electrons found on the highest energy level, the last ring, are what we call valence electrons, and they're the ones responsible for bonding, okay? Now, because what we're only really worried about are these highest energy electrons, we came up with a special way of doing electron configuration just to speed things up. It's called the noble gas configuration. here, let me lift this up. We call it the noble gas configuration. Okay. Now, what it is, it's a shortcut to the normal electron configuration. Okay. It's a shortcut. So let me give you an example here. We did phosphorus last time, right? Last time, this is what phosphorus looks like. I'm going to do this really fast. Phosphorus, for the normal electron configuration, was 1s, 2, 2s2, 2p6, 3s2, and then finally 3p3, right? That's the normal electron configuration for phosphorus here. Now, the noble gas configuration is a shortcut. What we're going to do is we're only going to look at the energy level where we find phosphorus. We're only going to look at this last energy level. So let's write that out. The last energy level we find phosphorus is this 3s2 and 3p3, right? So to show that, because look, this is what we're showing you right here. What do I call this last time, just a minute ago? This is what we called our valence electrons, right? The electrons found on the highest energy level. So what we're only worried about are the valence electrons. So that's what we're showing here by looking at the last energy level. Exactly, right here. Okay? So what we do is to represent the rest of this right here, what we're going to do is look at the noble gas that came before phosphorus. Remember, we're reading this from left to right then down. So if we back things up, here's phosphorus. Let's back up. Boop, 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 boop. Come right here. Boom. Who's the noble gas right here? Who's the noble gas? Because this whole line right here going down are your noble gases, if you remember from middle school. The noble gas that came before phosphorus is neon. So what we're going to do is put neon in brackets. Okay? By saying this, if you look, neon, this right here, this square box, is actually the electron configuration for neon. Right? Let's look. 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 6. So this is the electron configuration for neon right here. So what we're saying by saying neon is all of this. So now we can skip writing all of that and just write neon. Okay? So that's pretty simple. This would be the noble gas configuration for neon. Okay? It's just a shortcut. And again, now we can directly go look. Well, how many valence electrons does phosphorus have, right? Well, let's look. This is the highest energy level here. We have 2 here in the S and 3 here in the P. So total, we have 5 valence electrons. Not hard at all, is it? I'm going to do one more example with you just to make sure you have this. Okay? Let's look at one here in the 4th energy level. Let's go to, let's say, arsenic, AS. We're going to look at arsenic here. We're going to do the noble gas configuration for arsenic. Now, arsenic is right here. So who's the noble gas that came before arsenic? Let's back it up. This would be the noble gas that came before arsenic, and that guy is argon. So we're going to put argon in brackets here. Just like that. Okay? So all we got to do is list out this one energy level here. So let's look right here. We got 4s. How many do we go through? 1, 2. We can't keep counting because who do we hit right here? That's 3D. So we got to stop. So 4s is 1, 2. So we went through 2. And then we hit 3D right here. Everybody see that? So we're at 3D. Well, how many do we go through? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I stop because now it's 4p, right? So we go through 10 3Ds. And now we're at 4p. 4p is where we actually find arsenic. So arsenic is actually 4p. Where's arsenic? 1, 2, 3. He's the third one. Okay? So this is the noble gas configuration for arsenic. But I want to find out what the valence electrons are. And here's where people get tripped up a little bit. They try to count all the electrons here, where you can't. Because let's look at energy levels here. What is the highest energy level here? Well, we got this energy level 4 right here. That's an energy level 3. So 4 is higher than 3, so 4, we only want the highest energy level. And we got another 4 right here. So these two are the highest energy levels for this noble gas configuration. So if we want to count valence electrons, we only count the highest energy level. In this case, it's 4. So we're only going to count the electrons on the 4s. So how many valence electrons does arsenic have? He has 5 valence electrons. Was that hard? No. That was pretty simple, right? 5 valence electrons. Are there any, well, I thought this was a real class. I was about to ask, are there any questions? But I can't do that because I'm recording this. Guys, I hope this helps you with noble gas configuration. Just remember, you only read the last energy level you find the element, and you always refer the last noble gas before that last energy level. Okay? Thank you. Have a great day.